Hello and welcome back to Beginning C++ Programming. This week we're going to be talking about files, some basic file I/O, and we'll create a little project to kind of show you how it's done. So the whole reason we're talking about this is this idea of persistence. In all of the programs we've written so far this semester, if you do anything, if you add any information about a restaurant or whatever, once you end your program, all of that goes away. And that's because everything that we're storing so far have been in variables, and these variables exist in memory, in RAM. Well, RAM is volatile memory, so as soon as it loses power, everything goes away, or as soon as your program exits RAM, everything goes away. Before that happens, what we would like to do is actually to save a file to a disk, whether that's an SSD drive in most modern machines, or an old-style hard drive. We just need to be able to store something so that it's long-term, so that it lasts longer than you turning off your power. That's that idea of persistence. And so the way that C++ handles that is by using streams. So streams are sort of generic objects that allow you to flow data from one thing to another. This happens to be really easy for us because when it comes to writing files, we've kind of already been using streams. We use streams to write to files, to send stuff to NIC cards, to send stuff to printers. But right now, like the thing that you've been used to most often is that you also use it to pull stuff in from the keyboard and send stuff out to the screen. So all the things we've been using with cout and cin, those are streams. And so using the stream mechanic for files is going to feel similar to that. It just has a few other rules, like I have to actually create a file to connect to and a file object. I have to create my own stream object that I can use to write to that file, etc. But it's going to feel very similar to sending stuff to the screen or pulling stuff in from the keyboard. One of the simplest types of files to create is called a sequential file. So a sequential file just means that you start at the beginning of the file and you read all the way through to the end and you pull in sort of all the data. It is not the most efficient way of doing stuff, but the computer still uses a lot of sequential files, especially for things like options or whatever for preferences for your different programs. It's easy to just sort of write those, go through them all to be able to load a program the way you want it to run. But for us, we're going to store data there. Now, granted, a database would be a far better option, but this is really basic file I/O, and it'll allow us to be able to do this without, getting crazy. So this is what a sequential file looks like. It is a bunch of data, each on its own separate line, each line separated by a new line character. So that new line character is going to be helpful to remember that that's the end of our record. I really shouldn't say it's the end of our record. It's the end of whatever we choose for it to be. We'll talk about file formats here in a second. But the idea is that each line has its own new line character, and that'll help us to parse out the data that we want. The entire file is finished, terminated, with a special end of file character, EOF. And so that EOF is also an invisible character, just like new line is, if you've seen text files. And so the idea is that this will represent the end of the file, so we'll know when we get to the end. One of the things about reading files is that you don't know how far, how many records are going to be in the file until you get to the end. So we'll have to think about that as we try to parse the file and pull out all the data. The thing about sequential files, you have to start at the beginning and read in order until you reach the end of line character. Again, larger amounts of data, you'd want to switch to a database, but for right now, we're just learning how to write to a file, period. So whenever you're using a stream, you're not actually handling the file directly. This happens a lot in computer science, where you end up with an abstraction of something that's a bit more complicated. The idea is that you're not going to learn how to actually write to something in hardware, but there's a hardware driver that will do that for you. You don't even necessarily need to know how to interact with that driver, right? There's software that's already written that will do that for you, and it can do it in an efficient way. So what we're handling is this thing called a buffer. It's a bit of memory that we're going to write to that eventually will get pulled into that file, but we're just sort of manipulating the buffer. At some point, as you sort of write to the buffer, it may start writing to the file. It may wait until it's more efficient to do so, but at some point it is going to flush the buffer and synchronize to the file that's actually written on the disk. And that will generally happen when you close the file if you're writing. But it could happen earlier, it could happen later, depending on sort of what's most efficient. The idea is that you don't need to worry about that. You just have to deal with your stream object, and your stream object will take care of everything else. So files need to be opened, which loads the contents of that file into memory. And then you also have to close the file, which will write it to the disk if you're writing, or just close it and pull it out of memory if you're reading. To do this, we're going to have two separate file streams. Now, there is just an fstream object that does both input and output, but in general, it's safer to have these things separate. Generally, you're either reading from a file or you're writing to a file. You're not doing both at the same time. So in this case, we have an IF stream object, and we have an OF stream object. The IF stream object is for input file stream objects. The OF is for output. So input means I'm reading a file. Output means I'm writing a file. For you to use either of these, you have to include the fstream library in your project. So opening files. To open a file, which is to maybe prepare it to be read or written to. In this case, we're going to be writing. We're using an output file stream object. And you can call this anything you want. I have like my out file object. I actually just usually call it out file or something. A little bit shorter, but it still tells me, oh, I'm writing to the file. This is the file object I'm creating. But you just declare it as a variable, just like you would anything else. It's an OF stream object. And you call it my out file or out file. And then that object is something you can make method calls on. So here, I'm making a call to the open method and then sending a file name. Now, if you just send a file name, you will create, because remember, this is an output file stream object. So I'm either going to potentially open and write over a file that already exists, or I'm going to create a new file if one doesn't exist with that name. And that file is going to be located in the same folder as the exe folder, or where the exe lives. So in other words, I'm not going anywhere. Now, what you should notice that's because that is a local, essentially, path. So I'm saying don't go anywhere, just right here, create this file. That's fine for our purposes. But if you wanted to, you could actually put in a Windows or Apple path, I suppose I should say Unix path, to wherever you actually want to locate it. If you start with your C drive or your root directory, you can actually create not a local path, but sort of a global path that will find that location on your system. So anyway, this will write a file. For right now, you can just name the file, and it'll be right there in your project, in your C-line project. To write to the file, you have this output file stream object. It works just like cout. So if you want to write to the file, use it like you would use cout. There's absolutely no difference. Cout is itself just a stream that sends stuff to a different device. Then when you want to close the file, you should close the file. By closing the file, you're guaranteed that at this point, everything will be flushed. I shouldn't say you're guaranteed. Obviously, something could happen in the process, but the file will be closed. Everything will be sort of flushed out of the buffer, and you'll make sure that everything is written to the actual file on your drive. So it's important to close files when you're done with them. Here's an example. So you can use this in your own projects. But basically, I create an out file object. I connect it to something called test.txt. Ignore the iOS out. For OF stream objects, that mode, that output mode, is automatic, so you don't actually need to put it there. And then I do check to see is open. So notice I don't write immediately to the file. I check really quickly to say, hey, is this out file open? If it's open, then I want to write hello world. There's a few reasons why you might not be able to actually open a file. In other words, because if the file doesn't exist, I'm not opening a file, I'm creating a new one. So really it doesn't matter. Like whether this file exists or not, like, I'm going to create a new one. But what if I can't create a new one? What if I'm so low on memory we can't do it? What if I don't have permission to write to the directory that I'm trying to write to? So there are a few reasons why that might not work. So it's helpful to just sort of put that in a gate to sort of say, hey, by the way, if this is open, then go ahead and write to this file. If it's not, then I'm not going to bother with potentially getting an error because the file, I tried to open the file, but I couldn't open it for some reason. In other words, I couldn't create a folder here. I couldn't create a file here. You can format your file however you want. The important thing is that you remember how you formatted your file so that when you try to read it later to recover this data that you've saved, you'll know how to do it. So whether or not, like for here, I've got clearly two records holding the make, model, and year for two different vehicles. But, right, is it each like make, model, year all on three separate lines, or do I want to do make, comma, model, comma, year as one record on one line? I will say that the second one is far more popular. It's called a comma separated values file. And yeah, it's just more popular. But you can do it either way. Some ways are a little bit easier than others, especially if you don't have a whole lot of data that you need to worry about. Like for us, we're just going to do a grocery list. The grocery list will just be one word. So it's pretty easy to keep those all on separate lines. Now, to read to a file. I've saved to a file. Maybe my program's done now. Now I want to read that file so that I can actually recover that data and get all those items back. So to do that, we do it the same way we do a CN, except in this case, I'm going to use my getLine function. And so just like with the getLine function where we say, hey, here's, kind of getLine, here's where I want to grab it from. Instead of saying CN, I'm going to use my input file object. And then here's where I want to put it, right? I can put it into a string. I can put it into a data member in an object. I could put it anywhere I want, right? But where do I want to get it from? Where do I want it to go to? And remember, you're reading from a file, so everything is going to be a string at this point. If you want to, you could use one of the conversion functions to convert it to an integer or something like that, like s2i would convert your string to an integer. So now when you're reading a file, like if I'm writing to a file, I'm generally writing from some sort of a data structure, right? I'm writing from an array or something. So if I'm writing from an array, I'll know exactly how many things I need to put into the file. If I'm reading a file, I have no idea how big that file is. So I can't use like a for loop. I don't know the number of things. What I can do is use a while loop to say, hey, while I'm not yet at the end of this file. And so the way we would do that is while not, whatever your file object is called, .eof. That .eof method, it is going to return essentially true when you are at the end of file. So I want to continue so long as I'm not at the end of file. There's actually another method that's probably more common. It's called .good. And so it works the exact same way, but instead of saying while I'm not at the end, you're basically saying while the file is good, there's more stuff to read, keep going. And so you can use either one. Both are acceptable, but .good is probably a little bit more popular, even though it's the sort of the newer one maybe. So here is an example of how to read. Again, you'll notice that here I check to see if the file is open before I start trying to read from it. This one's actually more important than the writing one. Because the writing one, if the file doesn't exist, I can still just create the file. But here, if the file doesn't exist, there's no way I can read from it. So if the file isn't there, I'm sort of out of luck. But this is sort of important. Like the first time you run a program, you probably don't have a file there, right? Because you haven't created it to write the file. So if you automatically load as soon as you open your program, you're going to get an error the first time because it's not open. So because it doesn't exist. So here we can at least check to say, hey, if it's open, then I want to actually read from it. If it's not, well, then I can say that there's an error, or I can not say that there's an error. I can just assume that it's the first time. There's no data there. So I can start with basically an empty list of whatever I'm doing. But here's an example you can use if you want to, write files or read from files. That being said, let's move on to sea lion and actually start a project. So this is going to be a basic grocery list project. I'm going to create the grocery list as its own class so that we can sort of handle things there within the class. And so the first thing I'm going to do is right click on my folder here, my project folder. We're going to say new C++ class, and I'm going to call this grocery list. Could be anything we want though, and I'm going to have the header and CPP files. I'll keep separate files. All right. You'll see that it put in the include guards, so we're set to go there, and started the class for me. So the main thing with a grocery list class is that I'm going to need to have some data structure in order to hold my list. So let's make this private, just traditional, good data hiding. And so I'm going to start with something to hold it. For us, an array is probably going to be sufficient. A vector would probably be a little bit nicer, but we haven't talked about those yet. And so, yeah, here we'll start with private and create an array. It's going to be a string array, so I'm going to need to include my string library. Means I'm probably also going to want to say using namespace standard, although it's actually probably better to put the standard : in front of all of my string objects. But this is pretty common for classes. And yeah, I think that's it. So class grocery list, we are going to create a string array, and let's just call this my list. Why not? And here I have to sort of set an arbitrary limit, right? I can't create something that's infinitely big. I can't create something that's more. So there's going to be an arbitrary limit to the number of groceries we can have in our list. For right now, let's just say 50, although who knows how your family shops. The other thing is that because C++ arrays don't know how big they are, and I'm not growing it to a particular size, most of these 50 slots for strings are going to be empty. So I need to know how many have actually filled up, right? And so I'm going to create an int for basically list size. And I can actually initialize that to 0 there if I wanted to, but I won't. I'll use a constructor. And so there we go. So I've got list and list size. I don't really need to create a name for the list. This is going to be specifically for groceries. We're going to keep it as simple as we can. And I think that's really all we need. The other stuff we're going to need is a lot of public things. So, and honestly, I don't need to create getters or setters for either of these things. And the reason I'm saying that is because the list and list size are really going to be completely internal to the class. We're going to give public interfaces for the class to be able to add items to the list, remove items from the list. But there's not going to be a whole lot of, nobody else is really going to need to access those things directly. We're going to give methods to allow them to access that. So the things that, what are we going to need to do? Well, we're going to need to be able to print our list. So we'll say maybe print list. Print list won't take anything. And it will return void. Can't think of anything that would return. Let's see here. What else? We need to be able to add things to our list. So I guess we'll also say void add item. There we go. Add item could take something, or I could try to build in the user interface into that function. I've done this both ways. Really could go either way, but let's go ahead and say we're going to go ahead and just make this actually take something. So this will take a string, which we will call item. Then we want to be able to remove things from our list. So void remove item. To remove item, we could either take the name of the item we want to remove, or we could take its number in the list. We could go either way with this. I'm probably going to say let's have it be the item, the number. So let's do int item index. And we could actually create two different versions of remove item that allowed you to do it either way if we wanted to. So I've got the ability to add stuff, remove stuff, and actually display the list. Now I guess we have to do our two big ones, which are going to be storing the list and loading the list. So loading the list will be load list. Doesn't really need to take anything. If we use the same file for everything, again, we could create customization. We could make it so we had multiple types of lists where maybe every list had a different name. And so I saved it under a file name using that name as part of the file name. Totally doable. But again, we're keeping it simple. And then we're also going to have void store list, where we can save all of our items to the file. I think that's probably good enough. So then let's go ahead and copy paste. So what I'm doing here is I'm copying these methods because this is going to be the interface for my grocery list class. So I'm going to need to actually implement these methods now. I'll go to C++, the CPP file for grocery list, so grocerylist.cpp. And here I will just print those out so that I have a to-do list for me to fix things as I'm going along. But I'm going to need to include some stuff for sure. I'm going to need to include IOStream. I'm going to need to include, spell these things right. My keyboard is slightly elevated, so that's probably what the problem is. Fstream in this case, right? We use file streams for this stuff. We're also going to include string, and I think that'll be it. So using namespace standard, let's go ahead and start implementing these functions. Printing the list should be fairly easy. It's just sending stuff to the screen. So that's cout. Let's say grocery. Oops. I just need to put this in a string. Grocery list. Maybe a new line. I should close that. And maybe a little line. And then new line at the end of that. And then here, we actually I want to stop that, don't I? Because here I need to actually loop through the list and print all of the different values. Yeah, and so let's do that. So for int I equals 0, I less than, and we're going to say here, remember, I've got not only the list, but I also have the list size. So the list size will be helpful. It'll tell me how far I need to go. This index is going to start at 0, so I just want I less than list size, because list size will always be this number of elements, but won't necessarily, like, we won't get to that actual index in the array, because if there's 5 items in the array, remember it's going to be 0, 1, 2, 3, 4. So then I don't want to actually hit 5. It doesn't know what list size is because I forgot to tell it that this was a member of the grocery list class. So grocery list : now it knows, oh, okay, I know what list size is. I'm a member of this class now. And then we'll do I++. And we just have to riffle through the list. So the first thing I want to do is I want to cout. So here I think I'm actually going to cout I+1. This will get a little confusing over time, but the reason is that nobody ever starts a list at 0. So even though this is going to be index 0 in the array, I'm printing a 1 because it's the first item. That makes sense? I'm trying to make this a little bit more human readable, but we'll always know that what the user sees in the list is actually going to be one off of the actual index of that item. So item 1 is at index 0. It'll always be one less. And then I guess we'll put a period and a space. And then I want to print out list sub I. Not I plus 1, right? That first element is 0. So I'm going to say 1 for index 0, 1 dot, and then whatever's at index 0. And then that's it for that. Put an end line. That will riffle through all the different elements in our list. And I think we're good. So we've got a nice looking grocery list. Here, maybe I'll do one more C out and just kind of close up our list with another sort of a border there. And heck, if we wanted to, we could even do a border here, drop it down. It's trying to help me out. It's not doing very well because when I pasted stuff all over the place. All right. But I have the right number of dashes, which is important, and the whole reason I was doing the copy and paste. All right, so line, grocery list, line, all of our grocery list items, and we're done. Just need a semicolon at the very end of all of my C out arts and crafts, and we're done. I've got a nice, attractive looking list that I've printed out. Next item is going to be add item. So let's start by saying this is part of the grocery list class. And so then add item is basically I just need to add an item to my list. So whenever I want to do something, let's say that I have 2 items in my list currently. Those items are going to be at index 0 and 1. But my list size will actually be 2, right? 0, 1. So I actually want to place my new item into index 2, which will be 0, 1, 2, right? But that'll be the third item. So point being, list size is already the index where I want to put my new item. So I can just say list sub list size is equal to item. Now, once I've done that, I can say, well, I need to increase my list size, right? So I can do list size plus plus. And again, if we wanted to be really fancy, I could probably put a plus plus right here because that would calculate this first and then add to, and I just could do it all in one line. But I'm okay with people seeing that those are 2 separate things. I'm going to assign it and then increase list size. I need to be clever if I can be clear, and I'm not really saving any clock cycles by being clever. So done. That's our add item. Not hard at all. Here for item index, let's make the assumption that when I say item index, what the user is going to do is give me the number that they saw on the list. So if they say they want to delete 3, I'm going to kind of need to delete 3, right? Now this is actually kind of hard with arrays, right? I don't have a really good method like I would with maybe some other, data structures where I can just remove something and everything automatically shifts. So here I'm going to actually have to be a little bit clever, which is to say, if you want to remove something in the middle of the list, let's say I want to remove item 3, but there's 8 things in the list. That means that item 4 needs to become item 3, right? And item 5 needs to become item 4, and so on. And then we're going to have duplicates at the end when item 8 becomes item 7. So then I'm going to have to delete item 8, right? Whatever the largest one is. So right now we would know that I've got my list and my list size. So let's say my list size is 5, and I want to delete the middle item, 3. So then these are going to be indexes 0, 1, 2. So I actually want to remove the item at item index -1, right? And then keep going pulling stuff back until I get to, I guess, list size -1. So then let's start that. First, I'm just going to start shifting everything down. By shifting stuff down, I will effectively remove the item because I'm overwriting it. So let's go for inti equals item index -1. And again, the reason we're doing the -1 is because what they're going to see in the list is 3. But we actually want to start with index 2. Index 2 is the one we're wanting to get rid of. We just didn't show them the item 0 because that doesn't look right. So we're removing from item 1, and then we need to replace it with the next one. So then this is going to be so long as I is less than item size -1. Item size, sorry, list size. That makes a lot more sense. And then I++ because we want to do it for each one. And let's make sure it knows that it's a member of the grocery list class. So it knows it has access to the list size member. All right, so now I've got that sort of, I've got the item, I represents the item I want to remove. So, actually, am I going to go off the edge here? I might, so I may need to adjust that here, but we'll see. So I want to say that list sub I is going to be equal to list sub I plus 1. Okay, so that means if I want to remove index 2, right? If I want to remove index 2, I'm going to take index 2 and set it to index 3. Then I want to take index 3 and set it to index 4. At that point, I want to stop, right? So this is going to go on, but I only want it to go on until, so index 3 is equal to index 4. 3 is actually 2 less than the item size, not 1 less. The reason I'm going 2 less here is because I'm actually accessing this one over here, right? Now, we have a dilemma. It's not necessarily a dilemma. It's just a design decision. I have items 1, 2, 3, and 4, right? Now, 4 is equivalent to what this one was, but this one is still here. If I say that the item size or the list size is now 4, even though there's something there, no one will ever know. Whenever I print the list, I'm only printing up to list size. So 0, 1, 2, 3, and we don't get to 4, so that's perfect, right? So you would never know that that thing's still there, and the second we added another item, it would just replace this one. So I don't actually need to delete that item. I could just say list size minus, and we're done. If you don't like the idea of that string still being there, then you could always say, I guess it would be list sub list size -1 is equal to the empty string. But strictly speaking, that's not necessary, right? Like the fact that I have something left here doesn't matter because of my list size, these are the only values people will see, are the first 4. They won't see that fifth one. But again, there may be an application where it would be important to remove that. I just don't know that it exists. Right now, though, everything that we're doing is in memory. So now we get to the actual ones where we have a list. We actually want to load the list and store the list. Now, despite the fact that that's the order we would probably do things in, we're going to load the list and then store the list. I'm actually going to write store list first. The reason I'm going to write store list first is because I don't know how to read the file until I know how I'm going to write the file. And although I've got a pretty good idea of how I'm going to do it because it's so simple, I still want to make sure I kind of know what I'm doing first. So this is going to be a member of grocery list. And we will get rid of that semicolon, replace it with some curly braces, and we can now implement this function method, technically, because it's a member of a class. All right, so then to store the list, I'm going to need to create an sort of an out file object. So this is an OF stream object. I will just call it out file. Oops. Capital F for camel case. And then I should open that up. So out file dot open. Now I should say you can actually chain those, but for right now, and we'll just call this data.text. So now I've opened the file for reading, or sorry, for writing. Now I should decide, I'm going to do the if out file dot is open. The reason I'm doing that again is just because for some reason, if I couldn't actually write that file, if I couldn't create the file to write to it, I don't want to try to do something that's going to fail. So I'm just doing a quick check here to make sure that yes, the stream is open, it is working before I actually try to write to it. And now I can just write to it. So for us, for our grocery list, I don't need to store the indexes. The order that they appear in the list will work when we try to pull it back in and read and put them into indexes. And also I don't know that the order matters in my grocery list. So then let's go ahead and write everything in the grocery list. So the thing that I have currently in memory is what I want to store, and that's in my array. So then let's take that array and write it to the file. So this is going to be for int_i equals 0. Actually, this one, no. int_i equals 0. I less than, not item size, list size, I plus, and then I am going to just write all this stuff out. So just like I would with cout, out file, arrow, list sub I, and an inline. Done. Every single item will be on its own separate line. Now there is actually kind of an issue here, which is that I'm going to end up putting an end line on that very last item, which will create a new line that gets read when we try to read the list in, when I load it. I could try to solve that problem here. I could try to solve it in load. I think it's probably a little bit easier in load, so I'll just do that. But regardless, just know that that last end line is going to cause a very small problem where you may end up with a blank grocery item. If that ever happens, that's the reason. And so we can just try to solve it from there. But right now, I've done writing my file. Last thing to do, outfile.close. And we're done. That is how I store my list. More importantly, I know what my file format is. Every grocery item will be on its own separate line, separated by new lines. So then let's go ahead and try and load this list the next time it comes back. So load list. And what we're going to do is create an input file string object called infile.open. And remember, we need to open the exact same file we wrote to, otherwise we're going to not be able to find it. So this is data.text, same name, happens to be the same location, because it's always going to be relative to wherever your executable lives. And so then now that I've got that open, I again want to check to say, hey, if infile.isOpen. I don't want to try and break something if, for instance, that file doesn't exist. And we know, again, the first time we run this program, that file's not going to exist. So if infile is open, then we want to do something. If infile is open, Then we want to actually read from the file. Now, I don't know how many items are going to be in this, right? This is I'm probably going to load at the very beginning of a program. And so I'm going to load, hoping there's something there, right? But I don't know how many items are going to be there. So I need to use that while loop to just say, hey, while infile.is good, infile.good. Again, I could do not infile end of file, but both work the same, so it's your choice. So I'm going to go through line by line, keep reading lines until I get to the end of file. When I get to the end of file or run into another problem, then that will no longer be good and we'll exit the loop. So then I'm going to use readline. So what I'm going to do is, now from here, when I stored the list, I was taking from the array and putting it to, taking it from the array and putting it to a file. Here I'm taking it from the file, but I need to put it back into the array, and I can already think of something I forgot to do. But we'll get it there. So here I want to kind of do the exact same thing, but other way. So I want to put it into the array. So let's assume that the item size is 0, which I didn't do because I needed to do a constructor, and I didn't do it, forgot. But let's assume that our item size is or list size is at 0, and we have our array there. So then what I'm going to say is list size, which is actually going to be the string that I want to put stuff into. So actually, I can just do the read line right here. I want to come from the end file and go to list.listSize because that's a string. We're good. Read line. I teach too many languages. How about get line? That's the name of it. So we're going to grab from the file, put it to that list because that's a string. But then we also need to say list size ++ so that we're ready for the next time we go through. And we're just going to keep doing that for every single one. I'm going to say, by the way, if actually, it makes more sense to do it right here. If all right, I am going to cheat a little bit just because I want to make this work. I'm going to have a string called temp, and I'm actually going to do my get line, not put it into the list yet. I'm going to put it into temp. The reason why is because I just want to check to see if it's blank. Again, the reason for that last one where I put in that extra new line that the thing is going to read and try and think that it's a blank object, I chose to solve it here as opposed to solving it there. Delaying, this is what you get. But now I just have to say, okay, you know what? Let's store the object, that item, grocery item, into a string called temp. And then I'm just going to check real quick to make sure it's not blank before I put it into the list. So if temp not equal to the empty string, then I'll do my two things. List sub list size equals temp. There we go. So then I'll hold it temporarily just to check to see if it's empty. If it is the empty string, I'm not going to do anything. But if it's not empty, then I will put it into list size and then increase list size. There's probably a little bit more elegant way to do it, but again, I waited to the last minute to solve it by solving it here as opposed to when I was actually writing the file. Where there you would just not do the end line for the last one. Regardless, we've got our list loaded now. So everything is loaded up. We should be good. We do need to, because it is right, to say infile.close. Now, by the way, Could I put something, so I have the if is open. What if it doesn't open? I could try to do something there, but again, I know that the first time we run this, it's not going to be there because we haven't done anything yet, right? So if I try to load immediately, it's not going to be there. I'm not going to do anything, but that's fine because that means that my grocery list will just be an array that has nothing in it and a list size of 0, which is exactly what I want because we don't have any data yet. That does mean, though, that I need to write that that constructor. Actually, I don't need to write the constructor. I could avoid the constructor since that's not really the focus today and just put a default value right there. It's because this is an instance variable, I can actually just set a default value there, and so we should be good. Cheating just a bit for the sake of time. All right, so then let's go to main and let's just test this out. We could create a whole user interface, but instead I'm just going to kind of quickly create a grocery list, which means let's include the string library, but let's also include grocery list.h and our using namespace standard, and let's do it. Grocery list, sure. Remember, list here in main doesn't mean what it means in grocery list. I don't have access to that list, so we're fine. So we'll create an object of type grocery list, which is my list. Then I will say list.loadList. We'll do that at the beginning of each time I run this. We'll also do list.storeList at the end of every time I run this. And again, we create a user interface, but I'm just going to kind of do some stuff in the middle here. So let's start by, for this one, I'm going to do list.addItem, and I'm going to add item bread. If I can spell bread right. There we go. And let's even do list.addItem milk. We'll do list.printlist to make sure those items got there. All right. So I'm going to run this, and once it finishes building, always takes the longest to build the first time. Build finished. Here's my grocery list, bread and milk. All right, that's nice, but that's not important. What's important is that the next time I run this, when I load that list, because we're done, right? Our program has exited. Memory is cleared. The next time I run this, I want to load the list and get bread and milk in that list, but be able to persist and add maybe a new item. So let's say I want apples. Let's see if this works. If we correctly loaded and stored our list, this grocery list should say bread, milk, and apples. I've got some persistence from here. Let's go ahead and do that. And hey, it worked. We still have persistence. Those items are going to continue to be there the entire time. We could remove items. We could do spec. Let's actually do that. Let's, for our next one, say remove item. Remember, remove item actually takes a number, but it would be the number that I see. So I want to remove milk. Turns out I have milk. So I'm going to remove milk, print the list, and we should get bread and apples. Fingers crossed. Because, you know, these pedantic things, you can make mistakes every once in a while. Hey, bread and milk. I removed the wrong item. I removed 3 instead of 2. Well, you know, we could go in and try and solve that problem. It's just in the indexes that I've moved stuff from. But we do at least have persistence. And because I want you to kind of see where this is, you'll notice here in CLion, I can open up my files here, And this is where my grocerylist.exe lives. You could actually go to your file system and find that as well. But here is data.txt. And if I open it up, it's just a text file. In fact, if I were to add something here, cookies, and orange juice, right? Then when I run this, another time, actually, wait, what's my main say right now? I don't want to remove an item. Here, let's just print the list. Oh wait, I never saved that other file, did I? Does it automatically save for me? It did automatically save for me. Good. Right, so I can actually edit the list, and when I load it, it's going to pull up the correct items, right? So now we've got persistence and a grocery list, and yeah, hopefully you found that to be a useful example of how to read and write data to disk. All right, have a great week, and I will see you online.